Hello, everyone. I hope you can see and hear me. And yeah, we will start soon with the second webinar about mastering film-forming amines. And the topic for today is analysis procedures. So I ask everyone to mute yourself so that we don't have any turbulences in the sound. And as last time, we will record this webinar and will provide you a link where you can find the recording of the webinar, so you can have a look on it and share it to your colleagues if you like. Yeah, I think it's time to start. So welcome, everyone. Great to have you all here today. So again, a lot of people attending from all over the world. So it seems to be interesting for you. We will start today with a short recap from our first webinar with where we spoke about basics and guidelines and standards. And then I will introduce you a little bit to the basics of FFA analysis. So what is measured, what standards are there, and also some specialties when we're thinking about sample taking. And I will show you some analytical methods, which are the standard methods which can be used to detect the FFA concentration in the system. So for everyone who missed the last webinar, or just as a small reminder, the last time we spoke a lot about the technical guidance documents from the IAPS, so which are the most comprehensive standards for the application of film-forming substances. And there are two available. One is the IAPS TGD 816 on the application of film-forming substances in power stations, whether it's fossil or combined cycle or biomass. And then we have the IAPS TGD 1119, which is for the application of film-forming substances in industrial steam generators. You can all download them for free at the IAPS website. And what is the main improvement with this standards? It's the terminology that we are using now for our film-forming amine topics. We have the film-forming amines, which are the active substances, and this is ODA, OLDA, and OLA. And then there are the film-forming amine products, which are the commercial available products containing one or two of those active substances or FFAs. And also they can contain different other chemicals like dispersants, like alkalizing products. And so this is the FFAP. And then there is the group of film-forming products, which do not contain any of those FFAs, but also have film-forming effects. And all these three together are called film-forming substances. So this is the generic term for all film-forming products and film-forming amine products. In the following, I will talk only on the film-forming amines, as the technology for them and the chemistry behind it, it's very clear. And also the analytical methods are very known. So we will focus only on the first two products. And what is critical to know is if you're using a film-forming substance in your system, you need to know what's in it to make a proper risk assessment and also a customization to your plant. So you need to know which product is the correct for your application, and also how to measure and monitor it. So you need to know what's in it to find out all effects on the system. Okay, let's start with the topic of today. about the FFA analysis. Maybe you remember this graphic from the last webinar. So it shows the several steps of film formation when you start dosing. And what is important to know is that when we measure film-forming amines, we can only measure the residual concentration. So we do not know how much is on the surface. We can just look how much free FFA is available in the system. And as there is an equilibrium between the concentration in the system and on the surface, we are looking for a residual concentration to keep the layer on the surface stable, because there's adsorption and desorption, and this is happening all the time. And therefore, it's important, if you want to keep your protection stable, that you always have a residual concentration in your system. This residual concentration is depending on the application and it's depending on the product, but it's necessary to know that we are looking for the concentration which is free in the system. Again, there are some information available about the measurement principles and standards in the IAPS TGDs. If you look in section 8.5, you find two well understood and known methodologies for the analytic. First one is an extraction method, which works with methyl orange and chloroform, and this is known as the Silverstein method. And the second one is a reaction of a xanthine dye with the amine, and the common term is Bengel-Rose method for this thing. What you are not finding in the IAPS is a recommendation for the concentration, because this is depending on the product and the application itself. So if you're looking for a short-term application, you need much higher concentrations than if you have a continuous dosing. So you need to look at what is the scope of the application, what is your planned dosing regime, and then you can refer to the recommendations by the manufacturer or by the supplier of the product, how much the residual concentration has to be. Again, it's really important to know exactly what's in your product, which are you using, because this has also an influence on the used methodology. And second one, which is also very important, if you have a mixed or blended product with an alkalizing amine in it, it is not enough to just measure the pH, because this says nothing about the FFA concentration in the system, and you can have an under or an overfeeding without knowing anything. And so that's why if you're dosing an FFA-P with alkalizing products, you need to look for the pH and for the FFA to be sure that there's no risk to the system. Some specialties for sample taking I want to mention, because it's a little bit different than standard sample taking if you're looking or if you want to measure the FFA in your system. So of course, if you want to have reliable results, you need to have an accurate sample system, and you need to do the sampling in the right way, because most of the FFA analysis procedures are based on grab sampling, and there are a lot of things that can have influence to the sample, where you can get an under detection of the products in the system. So have a look that your sample system is correct, which requires that you have a working sample cooler. So the sample should be 20 to 25 degrees Celsius. And it's also good if you have different sample coolers for different streams, and do not mix the lines in between, because this can cause some wrong detection if you don't are looking for the right line for the right sample, then you get a misinterpretation of the results. And which is especially for the industrial applications, the sample flow should run continuously, but in most industrial boilers, they are closed all the day. So they should be open at least 15 minutes before taking the sample to flush the sample lines very good, and also remove the particles which can be settled down in the sampling line. So this is really the basics, but it's also valid for the sampling for FFA. But there are some additional requirements. As the name is saying, it's a film-forming product, or film-forming amine. So it will create a film everywhere, also on the sample bottle. So it's really important that you use a separate bottles for the FFA analytic, and best is you have a separate bottle for every sample point for the FFA analytic, and best material is PTFE, because this is less affected by film formation, and so you get a good results. As this sample bottle will also be covered with a film, you should flush the bottle several times with the sample media to get like a pre-treatment of the sample bottle surface. And or if it's possible, take the sample directly in the reaction tube, that you can immediately do the analysis, and because as longer the sample solution is stored in the bottle, the less concentration you can detect in the sample. There are some possibilities of adding a buffer solution to keep the FFA in the media and prevent filming of the bottle and under detection by that. So if you're looking for a longer sample transport or storage until it's analyzed, so you should try to use a buffer solution. This can be different for the different analytical methods, and there are some experience available depending on the different products and methodologies. Coming to the analytical methods. So the first one which I want to introduce you is the so-called Silverstein method, which is based on a British standard from 1983. And this is a very accurate method because the detection limit is very low, but requires some laboratory experience. So as more analytic you're doing, the better the results will be. And you can use it for a concentration between 0 and 2 ppm in the system. Here we have a specific buffer solution which can be placed first in the sample bottle to set a pH of 3.4 to 3.6, which will allow the methyl orange to form a yellow complex, which then can be extracted with the chloroform. And this color has a linear behavior in the range from 0 to 2 ppm. So you can easily calculate the concentration from the measured value. And you can see first step is to treat the sample with the methyl orange. So this sample, there is already the buffer solution in it. Then you use the methyl orange and the chloroform, and then you get a very turbid solution, and then you need to shake it for around 3 minutes, and then transfer it in a separation funnel, and then you see a clear phase on the bottom of the separation funnel, and this one is used for the analytic, not the orange one, only the slight yellow one on the bottom. And you can extract it and then make a blank reading in a photometer with chloroform, and then use the sample solution to get the right value shown on the photometric system. The second one is the Bengal-Rose method. This one now is also available from HACH, which is very good, because then you can have a program on the HACH DR 3900 and DR 6000. There's a program available which you can use to get the results for the Bengal-Rose method. And here you can see there is a slight difference between OLDA and ODA. So as said, you really need to know what you're looking for, because otherwise you get the wrong results. The detection limit is around 20 ppb. And what we found in one of our last application is that if you don't have if you're below the detection limit, you will get a negative reading. So which confused us when we did the first experience with this measurement system, but don't be afraid, it's not negative, it's just zero, just the reading gives a negative result. As the name is saying, it's giving a pink or rose colored complex, and you can see it here, though these are the two chemicals. This is the sample. Directly you can take the sample cell for doing the analysis, then you add the first reactive, and it's getting a dark rose coloring, and then you need to add the second one where the color turns into a slight rose color, and then you use it in the photometer, and you can see here it's shown as OLDA, and in the program you can switch whether you want to measure OLDA or ODA or OLA. So you need to be aware of that you're looking for the right product in the photometer when you use the HACH program. Also helpful are field test for a quick analysis, also if you have remote places where you don't have access to a photometric system. Very easy and simple test is the Lovibond tablet test for amine. This is detecting all long chain aliphatic amines, and the concentration is giving as a refer to ODA. So if you're using a different product, you need to calculate the right concentration. But to do the test, there is additional chloroform needed. Otherwise, you cannot get the extraction. And also the detection limit is 1 ppm, which is not useful for applications where we're looking for 0.1 to 0.5 ppm. So detection limit is very low, and I don't want to recommend you to use those tablets, because it's also really hard to get the tablet soluble completely. And my recommendation is don't use this for applications in steam or hot water boilers. Second one, which is very accurate, is the Chemetrix filming amine test kit, which is also based on an ASTM standard, very similar to the Silverstein method. You get a comparator with the test kit to do some readings. You can see it in the picture. There are in the center is the sample, and around are different colored samples, so you can compare the color to them and read the concentration outside of the comparator. So it's very easy. And if you have a handheld or a photometric system, you can also use the solution. You can extract it with a needle and place it in the photometer, on the handheld photometer, to get an exact reading. You just have to make sure that the pH in the sample is below 10. Otherwise, the test kit is not working accurately. And especially for power plant applications, there is the online monitoring system, which is provided by Walsh & Bull and Roberts from the US. And it can be used for both OLDA and ODA-based film-forming amine products. We recently made some experience when changing over from one to the other, so that you need to do some additional calibration. And it is measuring every 20 minutes one sample. The current system can handle 1 or 2 streams, but I think there will be coming up a new one which can handle up to 4 streams of samples at the same time. So it's very accurate and works in the standard concentration range very well. You need 3 types of chemicals, and you have to replace them. Also some hoses, but yeah, it's a very helpful system for continuous dosing. Here are some examples provided from our partner in New Zealand, where they have installed several of those systems in their applications. And here is a short summary of the different methods. So you can see the laboratory methods are very accurate. Half method has the advantage that you don't need additional chloroform. The Silverstein method, there you can store the sample for a while and do some transport with this without having it under detection. And as said, Lovibond tablets, I don't want to recommend them. If you want to do a field test, use the chemetric test set. They are very accurate and can give a quick information about the concentration in the system. Of course, there are only 20 of these sample tubes in it. So if you have a lot of sample points, it will get more costly, but yeah, it's the best field test we found so far. And last one is the online analyzer, which is really recommendable for all continuous application or continuous dosing applications, where you have also some more experience with online analyzers. So this is a very good thing to have. Okay, this was the quick overview on the laboratory and test methods for film-forming amines. If you have any questions, I would be happy to answer them. So just raise your hand or write it in the chat. So I will try to answer that. Okay, no questions so far?
Yes, I have a little question. Ronnie?
Okay, yes.
My question is, some of the examples I take without cooling first. Is it okay that I add the sample directly to the vessel with the buffer, and does it affect the measuring? Because sometimes it's very hot, it's not cool enough.
Yeah. So the thing with the temperature, so all the standards are referring to a temperature of 25 degrees. So of course, as higher the temperature is, this can be a issue with the analytics, and we strongly recommend to do to have a sample cooler, because all other values also need a cooled sample, whether it's pH or conductivity. It's all referring to 25 degrees Celsius. So otherwise, you need to wait until the sample has cooled down, but then you can have also some CO2 in it as well, which will affect not the FFA analytics, but the others. So my recommendation is clearly have a sample cooler and look that it's working properly, because otherwise you will get less accurate results.
Okay, because I tell you what, because if I take it without the buffer, then I wait, then it won't be useful. I wait too much time. And if I add the buffer and the sample is very hot, it's ruined. So what should I do in a situation like this?
Sorry, my voice was gone. Next one. So that interference with the test, no. So not so far. Just look at the pH. There are some recommendations in some of the tests regarding the conductivity as well, but the most important thing to look at is the pH in the sample. And here's a question about a new standard for degassed acid conductivity. No, there is no difference for the degassed acid conductivity when you use film-forming amine products. The same limitations are valid as if you're not using them. So it's the same standard. Okay, further questions? No? Okay, then, sorry. Thank you all. Thanks for your attention. Thanks for having you. We will have another part 3 of this webinar series on August 7, same time. And the topic will be about the continuous dosing of film-forming amines under cycling operation conditions. So hope to see you again in August. If you have going to holidays, have a nice time. And yes, thank you and see you. Bye-bye from Germany, Leipzig. Bye. And enjoy the football finals for all who are involved. Bye-bye.